Never, ever, never. Never, ever, never. You're the universe and I was revolving like a sun on my own. I know that you would do anything for me, but I just need to move on. I was running from a bad thing when I first met you. This is gonna hurt, but it doesn't make it any less true. I never really loved you. I never really did call you my only. I'm only holding on to something in my head because I'm lonely.
Thank you for joining me today on my channel where we do all kinds of projects and challenges that are Python related. I know after that intro, you probably have some questions like, what's that all about? Is he really that handsome? Is her husband jealous? You know, things like that. Well, what I can say is yes, he really is that handsome. And no, my husband is not jealous because he's a dummy. Hey! You also might be wondering what this has to do with the video, but if you stay tuned, you will find out. For Leetcode problem number 21, we are merging two pre-sorted linked lists. These lists can be empty, one can be empty, one not empty, one longer than the other, etc., etc. And no, this is beyond concatenating lists. I don't know if I'm saying that right. Concatenate lists. If you're not familiar with a linked list, object-oriented programming, nodes, classes, heads, tails, dummy nodes, or pointers, I highly suggest brushing up on those concepts before tackling this problem. But if you are familiar, let's dive in, shall we? Looking at the directions, Leetcode tells us we are given the heads of two linked lists, list 1 and list 2. And what we need to do is merge these two lists into one sorted list. And the list should be made by splicing together the nodes of the first two lists. Then we return the head of the merged linked list. By telling us we need to return the head, this language may seem a bit confusing. However, since we have an example output, we can know that ultimately we just need to return the merged list altogether. So how do we do this? Well, we do it through comparison. And we have our two lists, but it's best to think of these numbers in our list as nodes with heads, tails, and pointers. In your head, I want you to imagine our output like an empty list, and our first job is to compare our head nodes of 1 and 1 and determine which is greater. Since they're the same, we'll take the head of 1 and put it in our output. And next we set our pointer to the next node, which is 2, and compare that to our head node of list 2. Since our next node is greater than our head of list 2, we return the lesser with an else and put it in our output. And then it continues on like that until there aren't any more nodes. In this video, I have two examples that I'm very excited to show you. And please make sure that you hang out until the end of the video to see the results. Were we able to pass? Which one was faster? Which one was more efficient? So stick around to see how that all shakes out because it would make me so happy. For our first example, we're going to utilize a very common strategy using a dummy node through iteration. But before we get into that, I just want to point out that this problem utilizes a class and then a function within that class. It contains two objects, the value of the list and next. These objects are set up for you already at the get-go so that the program knows what to do. I just want to point that out from the outset, so hopefully there's a little bit of better understanding there. Okay, back to the dummy node. A dummy node is really nothing. No offense, dummy, but it's just a starting point and or a setup node that points to the first place in our output. To start, you can create two variables here, but I think that this is way more elegant to combine them into just one whole line, which you can do here by just creating your temp equals dummy, and we're calling our list node class 0, and then we want to take care of our event that our lists, or either one is empty or both are empty. So we want to be like, if not list 1, we want to return list 2, and if not list 2, we want to return list 1. Okay, we took care of those two things, and so now we can create a while loop that's going to loop through our lists while list 1, as long as there is something in the list, while list 1 and list 2. This is where we need to compare our nodes, or numbers, I guess, if you want to say, but they're called nodes. If the value of list 1, which again, up above, we have our class. It's already created the value object. So we can just go ahead and put that in here. .val is less than list 2 the value of list 2. Then this is where we want to set our pointer to the next, like that, to the next number. So this is our temp. We're setting up our temporary node, temp.next equals list 1, and then we're going to do the opposite. Else our temp, oops, hold on, our list 1, and then we need to reassign list 1, move it to the next pointer there, and then temp next, else it equals list 2. Then we reassign list 2, list 2.next. We need to tell our program where our pointers need to go based on the comparison of the elements, which one is less. Okay, and then we reassign our temp. Oops, I don't want to go down that far. Temp equals our temp next. Let me push it. Whoops, point it there. And that's kind of it. I know this seems kind of weird, but all we need to do now is just return. I mean, we're adding a couple if statements. So if list 1, if it's longer, this is our next cases. If the one is longer than the other, we're going to add on the, because we already know that it's sorted. So if there's the one list is longer than the other and we come to the end, we just add it on to the other list and it just continues on because it's sorted. Equals list 1, and then if list 2, the next node becomes list 1. Oh, I'm sorry, list 2. There we go. Now all that's left to do is just return our dummy. And we just return our dummy. Okay, that one is done. And that's it. That's it for our first example. That wasn't too bad, right? So basically, to reiterate, we have our two exceptions. If the list is empty, return the other list. So we do that for both lists. And then at the bottom, we have our two if statements. If one is longer than the other, then we just add it on to whichever one, you know, we add it on to our output, I guess we should say. And then for our while loop, we're doing a comparison between the two numbers, which one is greater, and then we're telling our pointer where to go next, and then we compare that. So, and then we take it and we're pushing it into our temp, and then at the end, we're returning the dummy at the end. So that's our first example. So hang on till the end to see the results of this code. And now it's time to move on to example number 2. Let's go. Hey there! If you made it this far and enjoy what you're seeing, why not subscribe? I upload fresh content all the time. Thanks for watching. Our second example for our next method uses recursion, and it reduces our code by several lines. And when I say that, it kind of reminds me of Pee Wee Herman's Big Adventure. Remember that movie? When they were at the Alamo and she was talking about preparing corn, and I forget the name of the actress. I'll have to look it up. When she was talking about them preparing the corn can be prepared many ways.
Is corn. Corn can be prepared many ways.
I don't know why that always comes into my mind when I say we can reduce our code by several lines. I don't know, it's funny.
You're really weird.
But by utilizing recursion, which is the function calling itself, it's very sleek and I love it because it's short. You know me, I always like the shorter code, even though it's not always better. I like it. It's good for me. Let's start coding. It's going to be very similar to our other code. We're still implementing the same principles, but using recursion, we can do that a lot faster and shorter. Let's get to it here. Let me start screen recording. Okay, we're going to do the same thing again. We're going to make sure our lists are not empty, or if one's empty, one's not. So same thing, if list 1 and list 2. This actually compresses this into a much shorter code. So we're just going to return list 1 or list 2, whichever one. That's it. And then we do another if statement for our comparison of the nodes. If list1.val is less than list2.val, what we're doing is we're returning the list node list1.val, and then self merge. Now we're calling this, we were calling the class. I'm sorry, we were calling the class. Now we're calling the function. So merge two lists, and our setting our pointer. This is so amazing. And then all we do here is add an else, and then we do the opposite. Else return list node for list2.val. Little m, merge two lists and list2.next, set our pointer, list1. And that's it. It's literally 1, 2, 3, 4, 5, 6, 7 lines of code. It does not get any sleeker than that. I mean, recursion isn't always the fastest, but it's pretty Pythonic to me anyway. So let's see our results and how they did in Leetcode. Are you ready? So that's it. The dummy node was definitely better, my love. Just kidding. I sent that video to my husband and I think he did get kind of jealous. It was kind of weird. I'm like, honey, he knows nothing about coding, so he didn't understand the reference. Anyway, thank you for watching my video today, and I hope you had fun, and I hope you got a laugh out of the very beginning of this video. I know that I got a pretty good laugh out of it, and it was so much fun to do. Anyway, thanks again. Until next time, happy coding. Bye.
Never, ever, never